Thanks very much, Jason, and thanks everybody. So we're going to talk about JSON data modeling today. All right, so most developers are probably already familiar with the relational way of modeling data. I assume we got a lot of .NET developers here, and you're probably comfortable with SQL Server, most of you that do work with databases. But if you want the benefits of a non-relational database, you're going to have to think differently about modeling. At least, well, maybe not to begin with, but eventually you'll want to think that way about modeling. So I'm at the Wisconsin, the .NET user group. Thank you to the Wisconsin group for the invitation. I appreciate it. I know you all meet in the Milwaukee area. I think that's right. But the last time I was in Wisconsin was for that conference a couple summers ago. I brought my family with me, and so we were at the Dells, and my kids just loved their time. We took a road trip there. They loved their time at the Kalahari, and I really, really want to go back and take the whole kids with us. So hopefully we'll get there. But for my reasons personally was all the fantastic pizza buffets that were around there. So I'm huge into pizza buffets. It's another thing that's taken a hit recently. So hopefully we'll all get back to that sooner than later. And we'll see you all in that conference. But my name is Matthew Groves. I am in marketing now. I'm a product marketing manager for Couchbase. So I mean to work on a lot of that baloney that developers get annoyed by. But I'm trying my best to make it less annoying and trying to be more technical, more useful, more valuable as much as I can. So you can contact me on Twitter, on LinkedIn. I have all those credentials there at the bottom. But let's get on with the presentation here. So we're going to talk today about why NoSQL. Why would you want to use NoSQL in the first place? You know, what NoSQL is, what are the benefits of it. We're not going to spend a huge amount of time on that. But I think it's important because many of you probably have not used NoSQL before, or maybe used it a long time ago. We're going to spend most of the time talking about JSON data modeling. We're talking about document databases, and that's mostly JSON there. And then we'll talk about how accessing data will have an effect on how you model your data, because you know it's not just getting the right model, but getting the model that's going to serve your application the best. And we'll talk about migrating and syncing data from relational to NoSQL, if that's something you want to explore. And then we'll have time for questions. Feel free to ask them in the chat there. We can take them. I can take them whenever you want to just throw out a question. I'm happy to answer questions and go off on tangents, things like that. So let's talk about why NoSQL. SQL relational databases, they're great. They give you a lot of functionality, a great set of abstractions, you know, tables, columns, data types, triggers, store procedures, all those things, ACID transactions. But why would I want to look at anything else? And I think the answer is because change is inevitable. And relational databases, I don't think, handle change as well as the NoSQL databases, non-relational databases that we're going to look at. And NoSQL databases, especially ones that are distributed, are going to help solve problems of change. So agility of the structure of my data, scalability. More people are using our system, or our system is getting hit harder. Performance, we need to reduce latency, things like that, and availability. If one server goes down, we need to keep the system going, that sort of thing. Let's talk about what NoSQL is first. So NoSQL is a term that I really, really don't like, even though I work for a NoSQL company. We use NoSQL terms all over our website. But it's just such a broad term, and I don't really like just referring to NoSQL because that means different things to different people. So I like to drill down a little farther and talk about what we're talking about: document databases, key value, wide column, graph. Those are kind of the big four. There's other types out there as well. And so key value and document are somewhat related. Wide column is kind of a variation of document, and graph is kind of the weird one out there. It's very cool stuff done with graph. But mainly I want to focus today on document databases because that's where the JSON, that's where we mostly see JSON being used. They originally came with a minimal set of APIs and features. So you're looking things up by key, you're replacing them by key, you're deleting them by key, and then you'll typically, because you're using JSON, you'll have some functionality like MapReduce that allows you to filter through the data and map it, and it's kind of a substitution for a normal SQL query. But this minimal set of features here doesn't use SQL. doesn't use tables, things like that. So that's where the buzzword NoSQL was born. These are databases that don't use SQL. Now that's the original reason for the NoSQL buzzword, and that we're a decade and a half, I think, removed from that coining of that buzzword. So it's changed a lot since then. So we're going to talk about document databases mostly today. I want you to think of them in the simplest way as just a type of key value store where the value is a known format. So I have data that's stored in my database. It has each document is a piece of JSON, a JSON object, and each one of those has a key. And so if I want to look up a document, I give the key to the database, and the database returns to me that document. That's sort of the simplest way you can think about it, is a specialized form of key value. And you think of the same way for replacing or deleting. It's just all based on a key. And the reason for that is because we want the data to no longer be tightly coupled to a table, let's say. We want it to be able to live on its own. Each piece of data can live on its own. And why? Because we're going to distribute this data amongst a cluster, amongst multiple machines. And that gives us the scalability that we're looking for in a distributed database. So we start out with maybe a small cluster of 3 machines. And each of these machines can provide replicas or can provide the primary copies or both. And if we need more capacity, we add more nodes to this cluster, and we can keep adding them as we need them. And actually, if we want to scale back, we can do that as well. Maybe there's periods of time where we don't need as much capacity. Maybe a few hours during the day, or maybe it's after the college enrollment season's over, we can scale these systems back down and save some money, for instance. And so that gives us a type of flexibility when it comes to scale. But we can also, as a kind of a side effect here, each piece of data is now completely independent on its own. So we get some flexibility in the way that the data is stored. So this is a situation that's really can be beneficial. We can more easily manage the change in business requirements. We can manage the change in the structure of the data. We can also, sometimes we're pulling together data from multiple different sources, multiple systems, and integrating them. And so that flexibility of ingestion really helps us. We don't have a rigid schema we have to follow. We can just import data from whatever source, and that may change from month to month if we're importing from dozens of different sources. Now, this means you have no rigid schema. It doesn't mean that you can just put in whatever data you want to. You should still have some discipline about your data, and we'll talk about this today. Availability, I mentioned this already. So if one machine goes down, the customers can still, your users, your customers can still use your system. And I took this picture of my wife a while ago. We were going to see Wonder Woman, I think it was, in theaters. And she was getting a soda, and I thought this is a perfect picture that demonstrates availability. So I told her I'd take a picture and put it in all my slide decks from that point on. Because if you go to AMC's theaters, they typically have a big array of these Coke machines, these Coke Freestyle machines. And one of them was on getting serviced. Maybe it was getting refilled, or maybe it was broken or something. And that's fine, because one of the machines was down. My wife was still able to get soda from the other machines. They didn't have to wait until 4 a.m. on a Saturday to come in and service those Coke machines. And the customers can still get service even while the machines are being repaired or machines have crashed or whatever. So that's what availability or high availability means. And the last reason is performance. So many NoSQL databases are focused on low latency operations for specific access patterns. And performance can be very subjective. It really depends on your workload. What are you doing? What are your goals with performance? So there's lots of benchmarks and things out there to compare different workloads, different databases. I like to focus more on architecture, like why would it be faster for this use case, more than the various benchmarks that get published by vendors, including Couchbase, that show how great we are, because we're not going to publish a benchmark that doesn't make ourselves look great, right? Same is true for everybody. So benchmarks are fine, but I like to focus more on the actual architecture features and why would it be faster. Use cases for NoSQL, there is a large list of them, and it's growing more and more. In the early days, NoSQL was a great fit for caching, session, for user profiles where you have a large amount of users, because we're going to give up some of those things like ACID transactions and SQL queries, but we're going to gain the scaling that we need, and user profiles are a great fit for that. That's in the early days, right? Those are kind of the bread and butter of NoSQL. But as NoSQL continues to grow, document database continue to grow, and feature set continue to mature, lots of other use cases get added. And you can see even at the bottom right there, finance. Even financial institutions, banks are using NoSQL databases. And this is because security features and ACID and SQL queries have been starting to make their way into the NoSQL world. But usually the catalyst is one of these reasons I'm talking about. So performance, flexibility, scale, high availability. Those are the reasons that people go to NoSQL. And I'll just finish off with one of my favorite quotes here about different isn't always better, but better is always different. So if you're looking to make something better, making a system better, maybe NoSQL is something that can help you. All right, so let's get on to data modeling. But I want to just pause for a second here. If anyone's got questions, I just want to remind you, throw them into the chat there, and I'm happy to answer those before we continue on. But I want to talk about data modeling a bit because storing data in JSON is different than storing data in tables. So I'm going to try to compare and contrast. Hopefully you're familiar with relational enough to, because I'm going to be comparing that a lot to a JSON data model. All right. So let's look at modeling a customer data here. So this is maybe what a customer will look like. And you might do this as part of a proof of concept or planning phase. You're just whiteboarding out some sort of concept that's going to be in your system. Maybe you haven't even decided on a database you're going to use yet, but we're just whiteboarding. We're just discussing it. And there's lots of things here that we can talk about that go into the structure of this data, how we might model it. So there's a rich structure here. This customer has attributes like name, date of birth. Potentially they could be sub-attributes. We could say, well, name isn't just name, it's first name, last name, or first name, middle name, last name, something like that. Date of birth could be month, year, day. Those could be broken up into sub-attributes, for instance. There's relationships. And we've got some potential relationships to other connections here, other customers in the system. So maybe we're setting up a streaming video website, and we need to have a family that are allowed to log in and view their own preferences in that system. But they all connect back to the main account, which is Helen here. We've got a value evolution that's possible. So maybe we have purchases here. Helen's buying items from a catalog, and as she makes more purchases, they add more items there to however we're tracking those. So we're evolving those values. And there can be a structure evolution we have to think about as well. This may be tough to think about up front because we don't know what's going to change necessarily in the future. But we start with billing information, some attributes for Helen like her credit card number and the credit card number expiration date. But then the requirement comes down that we need to accept multiple payment options. So we evolve our structure to now, instead of making credit card number an attribute of Helen, we split that out and say, well, actually, it's a collection of different billing options. So it's no longer directly an attribute of Helen. Now each billing option is itself a value that belongs to Helen. So we got to evolve that data. So let's look at modeling that in a relational database, because that's, even though I work for a non-relational company, I spent a lot of time in my career working with relational databases. And this is the way I learned data way back when I was in college. And so this is just kind of where my mind goes, is like, okay, we have a customer table, we need a context table, we need all these other satellite tables to do that, to achieve all those things that we just threw on the whiteboard. And then, of course, the most difficult thing I think for a relational database to handle is the structural evolution, where in that customer table there might be a credit card number column, but now with multiple payment options, we need to rethink how we're modeling this data. So we need to bring in a billing table, and that's a relatively simple looking change to make, but it involves creating a new table, creating copying the data from customer over to billing table, creating a foreign key, removing fields from customer, maybe creating new indexes, all these things, alter tables, statements, and that might involve operations that lock down your database. So now we're back to the 2 a.m. on a Saturday. Yeah, we can do that, but we need to do it at 2 a.m. on a Saturday too, so we don't affect customers, sort of thing. So structure evolution there can be problematic with a relational model. So let's look at how we might model that same customer whiteboard exercise into a JSON database or a JSON data structure. And I'm going to do this by just showing relation on the left and JSON on the right. So let's start really simple. We have one row of data in a customer table, and we're going to map that pretty much directly over to a piece of JSON, a JSON object. I'm going to call this a document. And you can see here it's pretty straightforward translation here from name and date of birth over to JSON. The one kind of minor difference here is that there's a document key instead of a primary key. Similar function though, it uniquely identifies that customer document so we can look it up by the key. And it's JSON data instead of a row of data. So far, pretty straightforward, pretty simple translation to go from one row into one document. All right. Now let's get a little more complicated. We have one row in customer and one row in purchases. And both of these things make up the customer data, but we model them this way in relational because that's their normal form. That's the correct way to model it, is to take a customer, shred it up into a bunch of pieces, store it in a bunch of different tables, and then when we retrieve it back out of the database, we glue it back together with an ORM or some tool like that, like Entity Framework, for instance, or NHibernate, something along those lines. And we have a foreign key to pull this off. So in the purchases table, customer ID is a foreign key that points to that particular row in the customer table. In the document version, the JSON version of this, we don't have to be constrained by splitting data into different tables. We can put a purchases array right in that JSON document that contains the same information. And we no longer need that foreign key because it's no longer foreign data. It's now domestic data. So we have two pieces of data in relational, but one piece of data in the JSON database. And as we start to evolve that, or start to evolve the values, we can add a second row to purchases table, or we can add a second item to the purchases array in the document database. So relational is now 3 pieces of data in 2 different tables. Our document is still just one piece of data by itself. All right. The next thing, let's get even more complicated. Let's introduce some connections, some relationships. And the way you might do this in a relational database is through a mapping table. Just go by different names, like a many-to-many type of table, where it has a composite primary key that consists of 2 foreign keys, right? So we have this connection, XYZ987, is connected to this customer, CBL 2015, and maybe some information about the relationship, like this is the person's brother, this is the person's father, or this was the date this connection was added, something like that. This, whatever we need about that relationship would go in that table. And sometimes the table is just 2 foreign keys. Sometimes it's 2 foreign keys and a bunch of other information. And so again, we have another table here, connections table, and 2 rows of data to represent those connections. Over in the JSON model, one way we could do this is, again, have an array, but the array itself we wouldn't nest all that data in the array, because now we've got an n+1 type problem where we're storing a customer within a customer, and then that customer has customers inside of it, and so on. That just doesn't work. So we just have this array refer to a separate document. So we have inside this document, CVL 2015, there's a father of this customer, and it's SKR007, so we can go and look up that document. So it's kind of like a foreign key in a sense. It's just a way to go look up the relationship here. Okay, and let's put it all together. So we have the 4 tables here, and so 2, 4, 6, 7 rows of data. And we can represent the same thing in one single JSON document over there on the right. So we have a JSON document represents a customer. or a relational model that is split into a bunch of pieces that you have to bring together to represent a customer. And now I want to focus on the structural evolution. So remember the whole thing with the credit card number. So I've made the rookie mistake here of putting the card number in the customer table. Not a good idea, probably. I want to split that out into a billing table so that we could have multiple billing options, perhaps. And I've made the same mistake over here in the JSON document as well. I've put those attributes there at the root level instead of putting them in an array. So let's fix that. Let's bring in a billing table and put multiple rows in there. And we'll do the same thing in document. We'll have a billing array with multiple entries in there. All right. So we've evolved the value of both of them. Now, the main difference here is that on the relational model, we've had to go through all those schema changes and those alter statements and the create table and create indexes and create primary keys and all those sorts of things. And that's for a relatively simple schema. And I'm sure that most of you have worked with schemas far more complex than 5 tables. The key thing here, and maybe you saw this, maybe you didn't, it would be easy to miss, is that this document here is CBL 2016, which can live in the same database as the old format, CBL 2015. So I could have both those documents coexist in the same database. I can just change the schema as I go if I want to. So different versions of a schema are not enforced by the database, but I can write them into there as I need to. And so this is a place where if you're used to relational, you're probably either thinking this is really awesome, I really, really need this, or you're freaking out saying this is terrible, we're going to have a huge mess of data. So this is where you have to be a little more disciplined about how you store your data. So we got a question here coming in the chat. I mentioned indexes. How do indexes apply to JSON and efficient retrieval of data? I will definitely cover that later on for sure. It's a really good question. Next one, is there a performance hit for JSON when querying for all the purchases data, for example? When querying for all the purchases data. So is there a performance hit? I mean, that's going to tie into the question there that Mike asked about indexing, right? and that's going to also tie into where I'm going with accessing data, right? So it depends on how you want to access this performance data, or sorry, the purchases data. Is it for operational reasons? Is it for analytics reasons? Like for a report, for instance, or is it for something that'll be happening a lot concurrently? And so we'll get into that for sure. How can security be incorporated? Well, I'm not going to talk about security very much in this session. We're talking more about modeling, but that's going to depend on which database you're using. But there are certain constructs I'm not going to go into too much. Like in Couchbase, for instance, we have the ideas of scopes and collections, which are kind of analogous to schemas and tables in SQL Server. So you can set individual permissions levels on those different levels of data. I'm not going to get into that too much here today. But let's, before you freak out too much about the versioning, let's look at some approaches to managing this data so it doesn't become a big mess of data with different labels and names and columns. So one approach is version numbers. And this is a simplistic version. We could put more than just a number in here, but let's say we've got a document that has just a name field, just one single name field, Matt Groves, and we'll call that version 1. And let's say, well, we need to actually split out first name and last name, so we'll go through and we'll have a different model, we'll call it version 2, that has first name and last name, and split those out into 2 different fields. All right. And so then when we're interacting with this data or in our application, we can then just kind of branch on that version number and say, if it's version 1, well, the name's going to be like this, map it to this object. If it's version 2, map it to a different object, or something along those lines. Maybe it can be more than a version number. It can be a .NET type, an assembly, however complicated you want to make it. And that's one approach we could take. Second one is, I'm going to call it Big Bang Re-versioning, where we just say, well, we need to update to the model, so we need to go in there and change everything to the new model.
So it's a one big update or a series of batch updates. So that's one route we can take. But this might have some consequences in terms of the downtime again, if we want to keep the system up while we make this change. But that's a possibility. Nothing wrong with this approach. And the third one is a little more complicated, I think, and so you need to know that going into this approach. But it's sort of a cooperative re-versioning, like a gradual re-versioning. So let's say you have a web application, and it's let's say it's a streaming service. So I log in to watch my videos, and this is, my data is currently in the format that has just name as one field. And I log into the application says, oh, hey, it looks like you haven't logged in a while. Would you, and this is probably a bad experience, so don't do this, but would you please split up your first name and last name for us so we can write you to the new data format? And that would be a bad experience. I've never seen that before, but you can apply it to other attributes. And you've probably seen this before when it comes to security, is if I'm using an old hash algorithm that's been broken, like say MD5, for instance. Well, I can't just convert that hash to another hash. I need you to come in and update your password, for instance, or change your password. And you've probably done this at least once or twice this year already. And that's maybe because they need to change the hash, for instance, or change the way they store passwords. So it's a gradual approach. It's waiting for someone to log in to make the schema change, for instance. Some of them can be automated. You may never notice it. So those are three approaches to managing those schema changes, and you can combine them if you want to. Maybe there's another approach I don't know about. Feel free, if you've gone through this process, let me know. There are some tools for going through this modeling process in a cooperative way with your team that are specific for, they have them for relational databases as well, but there's some for NoSQL databases. So tools like Accolade, specifically just for NoSQL. You may, I've heard of Irwin and Idera before. They make modeling tools for all kinds of databases, and they have some for NoSQL. And if you don't have a tool like that, or don't want to put up the money for those kinds of tools, there's some really basic tools like a JSON editor online that you can use. It's a no-frills offering that can help you with modeling and diffing and things like that. So those are some tools you can check out. Okay, so let's get off the whiteboard now, and let's get into, we're going to actually have to work with our data, and accessing it is going to very much inform how you model it as well. Because the way you plan to get data out can also affect the way you model your data. And this is some of the questions that have been asked in the chat very much allude to this, like what about indexing? What about if I want to access the data in a slightly different way? So I'm going to start with a some general guidelines that probably apply to just about any document database. Keep it kind of generic and useful depending on no matter what database you're using. And I'm going to dive into a specific database and some of the ways that it provides, and databases can start to diverge from each other about how you access the data. Okay, so let's start with NoSQL databases. You have multiple ways to access data. So it's not, in a relational database, it's only SQL. You're only using SQL to read and write data. With a NoSQL database, you have multiple ways to interact with your data, including SQL, ironically. We'll get to that later. But let's start with the basic way of interacting with data that I think every document database has, which is a key value operations. So you know the key already. It's really simple and extremely fast to access that piece of data. So this is some, I'm not going to call it pseudocode, but it's somewhat pseudocode, a C# example of getting a shopping cart by a key. So we'll just go to a collection, get that JSON data, and then we will serialize it to a shopping cart object in C#. Really simple, straightforward operation there. And we want to do the opposite. We want to create a shopping cart. We'll just insert a new, we'll use an insert command, give it a key. In my case, I use a GUID here, and give it a, say for instance, a C# object like shopping cart, which will then, at some point serialize that to JSON and store it in the database as JSON. So there you go. It's a really simple key value API, and these are the fastest ways to interact with document databases, because we know the key already. We can look it up very quickly. So if you can use key value, you should, because it's going to be really, really fast. So use that as much as possible. Since key value is so fast and easy, it would benefit us to use it as much as we can. So there are some ways we can be creative about our keys to maximize key value usage. So what I'd recommend is make the keys as natural as possible. Make them not just a surrogate key like an integer or a GUID, but make them something natural that would be unique, hopefully not be able to change, or if it did change, it would make sense to create a new document. So maybe something like a case number, or a social security number, or a phone number, or email address, something along those lines, or some combination of those might be a good key. The other thing you can do is make them human readable. So instead of just a GUID, make them, or just an integer, make them something like, oh, this is product 1, or this is product 555, so that I can see at a glance what this key is referring to. Make them deterministic, and I'm going to tell you what I mean by that on the next slide. But some way, a key that maybe you can construct the same way every time, so you can easily access it without having to go through any indexes or any other ways of retrieval. If you do all these things, your keys will be semantic, they'll be meaningful, and they won't just be a series of random characters that really don't have any meaning on their own. Make them human readable. So here's an example of what I mean by deterministic. So let's say I'm creating a blog or some sort of content management system, and I'm going to log into the system, and I'm going to update my article, or read my article, whatever. So the first thing I do is I get to a login page, and I type in my username and my password. My username is Matt, and my password. So just by knowing my username is Matt, I can go and look it up. Is there an author : Matt document? And does his password match? Okay, then he's logged in. Good. And now I have that information, and I can store that in a cookie, or session, or whatever. And then Matt wants to see all his blogs that he's working on. Well, I can look that up by taking author : Matt and appending : blogs to it. Look up that document. And inside that document is a list of all his blogs. Maybe he can add a new one to it. Or there's an existing one listed there he wants to view. So he says, okay, I'm going to check out my C#9 features blog. And that's a slug that's listed there in the second document, and I can use that to look up a third document. So blog : C#9 features, and that includes all my content, title, tags, date, everything about the blog post. And maybe the comments could be a separate document that I could, for make it easier for me to ignore the comments, I put them in a separate document and just append : comments to it. So I've gone through and stepped from one document to the next just by making them deterministically named, so I can walk through them without having to do any sort of secondary query or indexing or anything like that. I'm just doing it purely based on key value access. So that is, if you can do that and that works for your use case, that is the best way to go in terms of performance and modeling your data and modeling your keys. So some rules of thumb for that, because your documents are going to get more complicated than a blog. So if you are representing relationships in your data, and it's a one-to-many relationship, so much like the purchases situation from earlier, it makes sense to store those as nested objects. Keep them within the same document. So nest them all into one place. And if we are modeling a many-to-one or many-to-many relationship, so much like the connections we saw earlier, then it might make sense to store those as separate documents. Because if we are mainly, working on, if it's a situation where this connection could be connected to multiple places, then we want to keep those documents separate. So we're not duplicating, or we're reducing duplicate data there. Okay, now if we're talking about reads, if our read is going to be mostly on a parent field, so we're looking at Jane Smith's user profile, for instance, and we're just looking at Jane Smith primarily, then we can store all those children, all those relationships of Jane Smith as separate documents, because we're going to be reading, if we're going to get this document, we're going to get the whole thing and move it over the wire. So we want to move as small a document as possible over the wire. And if we're only working with the parent fields, or mostly working with the parent fields, and keep that document small and keep those other documents separate. And you can probably see where I'm going here. If we're reading parent and child together, so let's say it's a shopping cart, and we want to get all the purchases when we're clicking on View Shopping Cart button, we don't want to have to make multiple trips. So we'll just put them all together in the one document, and we'll retrieve the whole document as one piece. So it makes sense to store them as nested objects. Okay, and then we can go on to writes. If our writes are mostly parent or child, not both, but one or the other, then it makes sense to store them as separate documents, because again, we're reducing traffic, reducing the payload we have to move around, so keep them separately. And I think you can see where this is going. The last one here, if they're parent and child together, then store them as nested objects, because now we can update them all together in one operation, and that's going to be more efficient than multiple operations. So this is the slide when I do them in person, do this presentation in person. I would pause for an extra second or two because people want to get out their cameras and take a piece of this. But since you're just at home, just hit that print screen button and you can save that image. And I can make these slides available later too if you don't want to do that. But this is just kind of a summary of those last 6 rules of thumb that I went through there. So just think about what type of relationship am I modeling and how am I going to access those relationships. And these are rules of thumb. These are not absolute, this is the best way to do it all the time. This is just a good place to start. And you can feel free to violate these rules if it makes sense to. And I'm going to show some ways now where violating the rules might make sense. So the next thing we'll do is we're going to get into some data access methods that might vary from database to database. So not every document database will necessarily have this functionality. I just want to say that going forward, that everything up until this point has been pretty good guidelines for any document database or key value type of access to a document database. But another thing to consider is, does your NoSQL database have a subdocument API? So if it does, then you have even more flexibility. So the idea is this. Let's say we have a huge user profile document. It contains my username, my phone number, address, my purchases, my bio, whatever, all kinds of profile information, all my demographics, etc. And then I need to go in and, as a user, I want to update my address because I just moved, and I want you to send my newsletter or my coupons or whatever someplace else. So I just want to change the address. I don't want to go in and change the whole document. I just want to change the small part. Well, if without subdocument access, I need to get the whole document, transfer it over the wire, just update those 3 fields, and send the whole thing back over the wire. But if I have subdocument capabilities, then I can say, just give me this one part of the document, send it over the wire, I'll update it, and then send just that small part back over the wire and update just that one piece. So this can be very helpful if you have large documents or you're doing a lot of reads and writes that only need a small portion of the data. So if you have subdocuments, that's going to open up some more options for you in terms of modeling. You can be less worried about your documents getting real big, because now I can just update individual parts or read individual parts if I need to. Okay, so now we're going to go beyond key value access now, and I'm going to bring in Couchbase as a specific example of other ways that you can access data in a NoSQL database. So most NoSQL databases will have at least one other way to access data besides key value. And in Couchbase's case, it's maybe a half dozen different ways to access data. And this this is because modeling doesn't exist in a vacuum. We have to think about this, how we're going to interact with our data. So here's some examples from Couchbase. I'm not going to go through all 5 of these. We're just going to cover the 3 on the left there. So key value, we've covered that already. And you can see it's a direct line to the data, to the documents. So that's the fastest way to go about it. Couchbase has a querying language called NQL, N1QL, which is a implementation of SQL. So like SQL Server has Transact SQL, Couchbase has SQL. That's right. Couchbase is a NoSQL database with SQL. So if that doesn't make the NoSQL buzzword even less useful, I don't know what does. But notice here that it's not going directly to the documents. It has to go through indexes to access those documents. So it's an extra step that has to be taken there. We have to parse the query and look up indexes and go to the documents. So inherently, it's going to be slower than a key value lookup. However, you may have to do this. You may not be able to go through a key value lookup to do what you want. Full text search is another way. We'll cover that as well. And the other 2, analytics is really good for BI reporting type of stuff where it's very low concurrency but high complexity. And then the old kind of the legacy NoSQL thing is MapReduce, sometimes called views. Those are still present in Couchbase and many others, but they're kind of, they're kind of on their way out. They're not as flexible, and they have some downsides. So they're still around, but they're just kind of not being used as much. So let's look at NQL first. This is Couchbase's query language. NQL, it may look familiar to you because it's, like I said, it's just plain SQL with some extra stuff added for JSON purposes. But for instance, let's say we want to get all the users that have a Visa or MasterCard. Well, we can just do a where card type equals Visa or card type equals MasterCard. Doing this with just key value lookup is going to be very, very challenging, very difficult. You basically have to create your own indexes with documents. So instead of doing that, you'll just need to create an index on card type, for instance. So we gotta parse that query with a query service. We have to figure out the indexes to use. And in the end, we're going to get a bunch of keys to look up the data. So it's still going to use the key value system behind the scenes. It's just going to add some overhead to it. But sometimes this is necessary. So let's look at how this might look in a query plan. So I've got a different query up here. I'm selecting some airlines that have US in the name. So I'm using the like keyword here. So you got to understand the query plan. And this is true of any database, relational or otherwise. Because if the query ends up being slow, you got to go through here and figure out what's going on. So here's a Couchbase SQL query. I execute this. It ran in like 1.2 seconds. It's using an index on the type field, but notice the name field on there is using a like. And doing an index on a like field like that is challenging, if it's possible at all. So here's a visualization of the query plan, and you can see, if you've ever looked at a query plan before in like SQL Server, it's very similar. It's just different steps all the way towards the end. This is a relatively simple one. There's no joins or any unions or anything like that. But you can see that each part of this query has a certain cost based on the total time, certain percentage that it takes up. And the green ones are relatively fast. The yellow to red are relatively slow. And I can bring up a index advisor in Couchbase that says, oh, hey, maybe you should, this is the index you're using. Maybe you should create this index that would be faster. All right, so if I did that and I ran this query again, the query time goes from 1.2 seconds down to 146 milliseconds. So about 8 times faster. And then I can make a covering index, which would be even faster than that, because notice on line 1, it's selecting t.star. And if you use SQL Server, you hopefully are adverse to using star in any sort of query, unless you have to, because we're selecting every field. If we don't need every field, we can create what's called a covering index. And then we can skip the fetch step completely, and just get the data right from the index, making it even faster than 146 milliseconds. So that's the kind of things that are going to be helpful when you are trying to write queries against data in any database, and even a NoSQL JSON database. Okay, the next one is full text search. So this one revolves around text or even geospatial search or anything that's, I don't want to get too database nerdy here if I haven't already, but anything like inverted indexing is good at. So things like stemming, language awareness, facets, ranking, if you're using a lot of disjuncts, things like that. So this is a really simple example. I'm going to search for, I've created an index already. I'm searching for a keyword submarine, and I might get some results. And you can see that the word submarine is highlighted there in the results. This is different than a like in SQL because it's actually going to rank them by what it thinks is most relevant. And doing that with a like is challenging to do. So you use this instead of a SQL like, for instance. So there we go. So we now have 3 different data access strategies and my recommendations for each of them. So key value, I'd recommend use as much as you can. If you can get away with 80% of your operations using key value, that's going to be really good for performance. If you're using a good key naming strategy, an optimized data model, that's going to be very helpful. If you're doing any sort of text-based search, so like you have a catalog, I'm looking at the streaming service and I want to find specific shows with have a keyword in the name, then a full text search would be really useful for that. Or if I'm doing a geographical search, I want to find all the stores within 5 miles of where I am, then that would be a good search for full text search as well. And the last thing you want to fall back to is if you can't access it by those first 2 operations, then you can go to a SQL query. And I mentioned, maybe I didn't mention this, but joins are certainly possible in Couchbase with Nickel. But you probably want to use this sparingly because Nickel is going to have overhead to it, and you got to have good indexing, and that takes time to develop a good index. So that would be the option I would use if key value and full text search aren't going to work for me. Okay, so I hope that kind of answers some of the questions in the chat about indexing and performance. If not, we can keep going. I'm happy to take more questions about that. But the next thing I want to talk about is migration and migration strategies or syncing, because oftentimes, I'm sure as someone in marketing, I should say that you should always use Couchbase for everything. But the reality is that enterprises use a combination of databases often. So maybe you're not migrating from one to the other. Maybe you're just syncing data from one to the other. So that's fine. So just keep that in mind. I'm going to talk about this as a perspective of migrating, but it might actually be you want to sync data between them. Either way. So these are some of the typical options for migrating. I'm not going to read all these to you, but kind of the idea here is that number one is a complete, total, big bang rewrite. We're not going to migrate our application over. We're going to just write the whole thing over. We're going to rebuild it from the ground up to use a NoSQL database. And that is going to be the best way to take advantage of NoSQL features. But it's also going to be the highest effort and highest risk to go that route. I'm sure you've never been on a project like that before. On the opposite end of the spectrum is, I'm going to call the just hosted, or I'm going to call it the lift and shift option, where we have an existing relational model, and we're just going to take that data as is. We're not going to change the model. We're going to put it in a NoSQL database and see how it does, see how it works. And with an eye towards moving up this ladder later, so we can optimize it in places where, we're not getting as good a performance as we hoped. We're going to rethink our model and optimize and maybe start to collapse some of that data down. Question came in, do you have to maintain those indexes as you insert new data, or is that covered by the tool set? So the indexes I talked about, which was in Couchbase's case, the Nickel indexes, the SQL indexes, those indexes and the way Couchbase works is that when you insert new data into Couchbase, the indexes will get updated automatically. So if I'm querying on, what was it airport name or something like that, if I add a new document that has an airport name, that's going to cause the index to be updated with that new data automatically. Now, one of the things that the way Couchbase works is it does this asynchronously. So it will not by default anyway, it will not wait for that index to get updated before saying, okay, your data has been inserted, you're done. Now, if you wanted to, you could use the API and say, insert this data and tell me when the index gets updated. I'm going to wait for the index to get updated. So you can do that. Of course, it adds more latency to your operation. So, but if it's really important that you want that index to be updated, you want to wait for the index to be updated, that's an option. You can go about doing that. That's with Couchbase. And I assume indexing works similarly in other databases, although if we're talking like Cassandra, things like that, that's a whole different story. So, but we're sticking to JSON databases today. Okay, so this is kind of the spectrum of options for migrating data. We're going to look today at number 5 in the demo, kind of the just hosted option. But rewrite is definitely an option that's out there. If you're in a situation where we really need to just blow this thing up and build with all the NoSQL features right away, that's an option as well. But just keep in mind, it's going to be a lot more effort and a lot more risk. There's some tools out there to help you maybe reduce that risk, no matter which option you're going at. So some tools you might have heard of is Informatica and Talend. You may have heard of these before. Kafka is good because you can basically stream from any source to any sink with Kafka and vice versa. So you can stream data from relational to NoSQL or vice versa, and that would be the more real-time option. Apache NiFi is a tool that I think is very, very cool and criminally underrated. Hardly anyone I ever talked to has ever heard of Apache NiFi. So I'm getting it out there to you. Tell everyone in Wisconsin about Apache Wi-Fi because it's amazing. It's a data flow visualization tool that I was actually introduced to by working on a project with the Cincinnati Reds here at Couchbase, and they were using NiFi to move data around. Maybe I shouldn't say that to a group in Milwaukee because we're central rivals, right? But anyway, it was very cool to see their flow of data just being mapped around, and it was a visual tool. It looked like a giant piece of graph paper, different data sources and flows and arrows, and you could see the data move all around. It's very cool. Glue Sync is actually it's a Couchbase SQL Server specific tool to sync data from SQL Server to Couchbase, which is very cool. CData is a company that makes a lot of ODBC and JDBC drivers, connectors, things like that for a wide variety of databases. There's some I didn't mention, like Dart is a very cool option. Debezium makes a lot of drivers, connectors. Spark may be useful for this sort of thing. There's also the build your own option, which I'm kind of going to show you a little bit today in a demo. There's great scripting capabilities of Python and shells like Bash that have even PowerShell, things like that. They can take advantage of just curl and rest and just paste things together and start moving data around. Couchbase comes with an import utility called CB import. You can import CSV or JSON data. Mongo has a similar tool called Mongo import. If you're using SQL Server or Oracle, they have tools like SSIS, integration services, or Golden Gate, you can use to move data around. Or if you're like me and you're still, if you started out like me and you were stuck on SQL Server 2000 for a good 5 or 6 years, back in the day, you had a tool called DTS. So I don't know if that's still around or not, but that's another option. So I would say we're going to start at level 5 here. The simplest possible migration option is we're going to export data from relational into CSV, and we're going to import that CSV into NoSQL just as is, and just make that a raw copy of the data, a lift and shift sort of thing. Just treat it as a relational database to start with, and query it the same way. So lots of joins, lots of strips of data everywhere. Now, but once you got that in place, you can start to transform the data using those modeling techniques we've discussed when you need to improve performance, reduce the need for joins, reduce the need for querying even, reduce the need for ACID transactions. Maybe just do that one aggregate route at a time. So maybe start with a user model and go from there. Start with the slowest part of the system and model it to take advantage of the NoSQL capabilities. And once we get that in place, we can start kind of a transformation from the raw system into some sort of future optimized or progressive optimized system. And at some point, we can then start to think about that first step as a staging area before the data gets transformed into the optimized model. And this would be anywhere from like a level 4 up to a level 2. And this might be good to have a proof of concept here to say, well, let's try it and see how it works. You know, we're not going to commit to anything, but just try it out. Is this going to give us, is it going to meet our performance goals? Is this going to be faster? Is it going to be at least as fast as what we have now? But it's going to give us the scaling and flexibility benefits we want, for instance. So lots of options to consider there. And I think just in the end, you got to align with your data model, your migration approach, and your expectations. So keep those things all in mind. If you don't model your data to take advantage of JSON and NoSQL capabilities, then you might not realize all those benefits right away. So just keep that in mind. As if we're going to do a lift and shift, it might be some places where you definitely need to make changes to meet your performance goals. So lift and shift may be good right away, or it may take a little bit of work. Okay, so I want to go into a quick demo here. We'll show a little code and actually show some databases in action. But I want to just pause again. I think there's a little bit of a lag between the streaming and my actual voice going into this microphone. So I'll give people a second to ask any questions before I dive into a demo. So John asked, how does the scaling work? Is it like Redis or distributed cache? So if you're asking about Couchbase in particular, I can go into that into some detail. Okay, you're asking about Couchbase specifically. I think it's a different model than Redis. So the way Couchbase works is called a shared nothing or masterless architecture. So Couchbase, the way it works is it's all the same piece of software that goes on every single node in a cluster, and all those nodes talk to each other. There's nothing like a load balancer or any sort of orchestration, zookeeper, nothing like that goes in front of it. And the way Couchbase works is that, you know, there's some systems that are traditionally called master slave, or these days we call them primary, secondary. Is that you go everything through primary, and then secondary is like a backup copy. The way Couchbase works is that every node is both primary and secondary. So every node can do reads and writes, some portion of them. So as you scale out Couchbase, as you add data nodes to it, the data will be rebalanced so that every node contains, you know, some percentage of the data and therefore some percentage of the operations. So that's the way. That's kind of the short story. You know, I have a whole blog post I just wrote about it. If you go to blog.couchbase.com, you can check out kind of the comparison of how Couchbase scales versus how Mongo would scale. I don't go into Redis specifically. Redis is a little different because for the most part, it's a memory-only type of architecture. So scaling replication concerns are a little different with that one. I would say, if you're interested in more about Redis, I know a guy here in Columbus, Ohio, who might be interested in talking to you about Redis. Okay, I'm going to go over to a little demo time here. So let's start with SQL Server. How many people have see this screen every single day of their life? So this is SQL Server. I've got AdventureWorks 2016 loaded in here. It's a little bit outdated. AdventureWorks is, but I think it's a really good schema for this demonstration. Or sorry, a really good sample data for this demonstration, because AdventureWorks is a complicated schema. It's a lot of tables, a lot of relationships, and a lot of different features of SQL Server. So you can see there's like a human resources schema, a person schema, and inside that schema there's tables. So human resources has department, employee, etc. Person has address type, etc. So this is a relatively complex database example. I think it's a good one to work with. Your database may not be as complicated as AdventureWorks. Some might say AdventureWorks is overcomplicated. I won't argue with that, but I think it's a good example to use here. So we've got AdventureWorks is the database or a catalog. It's what's called in SQL Server. It contains schemas like human resource, person, production, etc. Each schema contains tables, Each table has indexes, and then not in AdventureWorks, doesn't have any, but you can create users that have, I guess I am going to talk about security today. Each user can have permissions that are fine-grained down to the table level if you want to in SQL Server. Okay, so I have written a utility. This is an experimental utility. It is not anywhere close to production ready, but I'm working on it as more of a educational tool, proof of concept tool, but I call it SQL Server to Couchbase. That's what it's called. It's actually, I think I'll have a link to it later, but there it is on GitHub, SQL Server to Couchbase. It's a library to automatically create and copy data from SQL Server to a Couchbase, what's called a bucket. And it does this by reflecting on the database, creating the structures necessary in Couchbase, and then copying the data over. It uses Dapper actually behind the scenes to get the data from SQL Server, and then uses the Couchbase SDK to put data into Couchbase. All right, so this is a sample console program here that comes in this project that I'm going to use to run this translation. So I've got a connection to SQL Server. I've got a connection information to Couchbase. This is just a config file here. And I've got some other settings, but I want to create a Couchbase bucket, create collections in that Couchbase bucket, create users, create the data, create the indexes, all based on SQL Server information. And I've actually got sampling turned on here because I don't want you to have to sit here for 20, 30 minutes while data is copying over. So sampling was just going to get a small portion of the data. So let's go over here to Couchbase. So I've got this AdventureWorks 2 bucket already set up. I actually have the full AdventureWorks already copied over into AdventureWorks 2016. I need that for something later this week, so I'm not going to mess with that today. But we're going to go from AdventureWorks here with 0 items. Notice 0 items in it. And we're going to copy some data over automatically. So you can hear I've got no scopes, just have the default scope, and no collections other than the default collection. This is the Couchbase UI, by the way. So I'm going to go ahead and run this console program here. AdventureWorks 2, so make sure I have the right one. Okay, go ahead and run this. This is just going to spit out a bunch of log messages to the console as it's creating structures in Couchbase and creating indexes now in Couchbase. And it's only going to create a small portion of indexes because indexes take longer. I haven't quite got the optimization down for that yet. This is experimental. And then it's going to start copying data over. So let's bop back over there. And items are going to start trickling in here. This is going to change from 0 to some other number. And we'll click on scopes and collections, and we'll see that it's created automatically for us all the schemas, all the scopes, they're called in Couchbase, that correspond to those schemas in AdventureWorks. And if I drill into, say, person, you'll see all the tables in SQL Server result in collections being created in Couchbase. Okay, and if I dig into, say, address, now all the rows of data in the address table are now become documents in Couchbase. So this is a list of all the documents in the person scope and the address collection. And so if I click on edit for one of these documents, this corresponds to a row of data in the address table in the person schema in the SQL Server database. So it's JSON data this time, right? So that roughly it corresponds pretty well to the data types available in SQL Server for the most part, right? So strings, varchars and nvarchars go to strings, integers and floats go to numbers, and so on. Notice here that I like showing address because there is a data type in SQL Server called geography, which represents a specific location on a map. And what my utility does is it actually translate that into a JSON object. So you can see here spatial location there on line 8. There's actually all the characteristics in a JSON object. So latitude, longitude. If there was a Z, there'd be a Z value in there, etc. So I think that's pretty cool. I like this a lot. I'm having fun with this. I should say. But let's see, is our utility done? So yes, so it's all done running. Notice that I only have a sample of the data because I don't want to wait here all day. 4,700 rows of data were copied over, basically. All those scopes were created, and all the collections in the scopes were created. So that corresponds exactly to the SQL Server data structures there. So the next thing let's do, and I should have had my little cheat sheet open for this. So give me 1 second, and I will get that open. Let's see. So 2021 JSON data modeling. We'll go this one here. Yes. Okay. All right. So let's go to this query tab. I'm gonna put in some. Let's do this. Instead of AdventureWorks, let's bring in travel sample. I think this will be a little more interesting to see some JSON specific things. Although we can do some AdventureWorks queries if you want to as well. So let's go here to travel sample. So this is going to bring in some data that ships with Couchbase. So this is kind of like Couchbase's AdventureWorks. It's travel sample data. And inside inventory, we've got just a few things: route, landmark, hotel, airport, airline. Let's go over here to query. You can see all those same collections there. Fine. Looks like the documents all moved over. So let's do this. Let's paste in a query here. I want to select everything from the travel sample bucket, the inventory scope, and the route collection, and give me everything where the source airport is Columbus, CMH. That's where I live. So let's go ahead and execute that query. And there we go. We've got a results are JSON here. So you can see the query results. There were 63 total results here returned. So there are 63 routes that fly from Columbus to some other airport. All right, and I can view this as JSON, and you can see here we've got this schedule, which is an array of objects, but it's JSON data there. Okay, interesting, except if I want to show this to a customer, it's not going to be terribly helpful, because if you look there at line 4, the airline ID is airline 321. Okay, it doesn't tell me as a customer anything, so I need to figure out the name of the airline. So a join might be in order there. I'm going to join to the airline documents. So here is an example of that join. I'm also changing it from select star to just select the fields that I want to show. I'm going to select from the routes collection, join that to the airline collection, where the airline ID, and notice the meta ID out there. That's a little bit of Couchbase specific stuff. That refers to the document key I mentioned earlier in the presentation. We're still going to limit this to Columbus CMH. Go ahead and run this. And now our results show that airline 2009 is Delta. And looks like they're all Delta here on this page, for instance. But we'd see the airline name, which would be what we want to show the customer trying to book a flight. So there we go. Now, yeah. So that's kind of what I want to show. Indexes. Someone asked about indexes. So let's go to AdventureWorks 2. Well, there's not going to be very many indexes there because I only copied over 5. And I don't even know which ones there were. Let's go to the full AdventureWorks here. Good person. So here's all the indexes that I basically just copied over, translated from SQL Server to Couchbase, because the syntax is very similar. It's create index, index name on the collection, and these are the fields I want to index. So this one is just row GUID, which you can see if we go over here and look at SQL Server indexes. There's all the indexes right there for that person table. And I just translate those over to Couchbase indexes. Now, you might say, my experience with SQL Server is that you either have a data sample like this that's heavily indexed, maybe even over-indexed, or I work with a database that's criminally under-indexed. There's not enough indexes because it's, the table scan is automatically built in. You don't have to worry about creating an index to run any sort of query you want in a SQL Server, which is a bad thing because the query can end up being really slow. One thing that Couchbase does by default is you can't do a full scan of data with a query. until you have an index created. You'll actually get an error message that says, hey, there's no index for this. I won't query this data. So you kind of have to then, okay, well, now I need to create an index. I can create a primary index that allows me to scan everything, but I have to opt into that. And again, we want to kind of guide you into performance there. But that's going to vary from database to database as you go forward there. Okay, so any questions on this? This is kind of all I wanted to show with the demo. I'm going to go back in and finish up with a few summary slides. But before I do that, just want to see if anyone has any questions about Couchbase or anything else I want to see in the demo. One thing I forgot, security. Back over here in SQL Server, AdventureWorks doesn't come with any interesting users for security reasons. So I created one. Let's look at this one. I call this one person microservice. So this represents a user that I might want to give credentials to a specific microservice. Or maybe it's for a multi-tenant application, something like that, right? So I've given this user very specific access to just these 3 tables, and it gets insert, update, and select permission to all those tables. And I think I gave business entity, I gave it delete permission there as well, which is probably a bad idea. But just for demonstration purposes, I gave it those very, very fine-grained permissions. So you can see here the checkboxes, business entity, I gave delete. I probably shouldn't, but I gave it delete access. That also gets translated over into Couchbase. Under security here, I've created some users automatically. Well, these are new. Why are those in there? Oh, okay. Anyway, that person microservice has all these fine-grained permissions here. It looks like a huge mess, but I could go in here and edit this and see all the specific permissions that I've given this user by default, or not by default, by just reflecting on the SQL Server options there. So there's the query options. It has select permission. It only has delete for that one collection. So very fine-grained permissions are possible there. I will say this is the enterprise edition of Couchbase I'm showing you. Actually, this is the beta release right now, the Couchbase Server 7 release. If you want fine-grained permissions, that's an enterprise-only feature. With the community edition, it's much less fine-grained options there. So I want to show you security, showing you indexes, and SQL query. Okay, I think we're good. So that's something I've been working on for a level 5 approach. If you're interested in that, you know, I love to get feature requests and suggestions for that tool. You don't, you know, pull requests are welcome, of course, but you know, if you just have a cool idea, like it'd be cool if this tool did this. I love that kind of stuff. So feel free to go check out that repo on GitHub and submit something. So let's wrap up here. Again, feel free to throw more questions in chat. Happy to discuss them as long as you know, Jason doesn't kick me out here. I will answer questions all night long. They say you only remember like 3 or 4 things from any given presentation. So here's the things. Here's the things. First thing, pick the right application. Do you need better scaling? Do you need flexibility? Are there performance requirements that you think you can hit with NoSQL? Do you need high availability? Pick the right application for these things before you dive into NoSQL, because you know there's no reason to you know play with NoSQL at your application that you're working on unless you have one of these pain points. So pick the right application for that. Do a proof of concept. You know, go through the modeling exercise. Create some success criteria. Like, you know, our application right now, this query takes 3 seconds. We wish it would take, you know, milliseconds. Okay, that's a success criteria. So go into a proof of concept with just that and have that focus and use that as a way to review the architecture. You know, is this database going to work for us? Is NoSQL the way we want to go? Does the modeling make sense? And you can even use the tool like the one I'm building in a proof of concept to go through that process. Think about the data access methods. So we went through just 3 of them today: the key value, you know, a text search, and a secondary query. In Couchbase's case, it's SQL. It's a nickel. Other NoSQL databases have their own query languages that perform secondary type lookups. But match those data access methods to your requirements as best you can, and always use key value. If you can, fall back to querying or full text search for other use cases. Got some blog posts here that you can check out. I'll give you a chance to screenshot that, or again, I'm happy to share these slides. And I guess there'll be a YouTube video afterwards, so you can always refer to that. The first one just came out like a few weeks ago. Those other two I wrote years ago, but I think they're still relevant today. A lot of the same stuff I covered today. A blog post about creating a proof of concept. What are the steps I need to create a proof of concept? You can find me on Twitter. This is my gorgeous family on a cruise. Another thing that I miss dearly. I hope we can get back to soon, because we had a time of our life on there, except my enormous head can barely fit in the picture. You can also, if you have Couchbase specific questions, like how does the scaling work, or how do those indexes get updated, you can go to forums.couchbase.com and ask away in there. Next steps for you, Couchbase 7 is currently in beta. We hope to have a general availability release later this year, but right now you can download the beta, try it out, test it out as much as you want to, do whatever you want with it. Give us some feedback, try it out, tell me what the worst parts are. I love that kind of feedback. If you want to join a Couchbase community to discuss it further, if you use Couchbase already, for instance, you can go check out the influitive.com. That URL there will give you invitations. I think it's kind of a soft launch, kind of closed community, except by invitation. So you're welcome to go to that URL there. And there's the GitHub link for the tool I'm working on. So if you're interested in that, maybe just interested in seeing how I reflect on SQL Server and how I'm using Dapper to do that. That's a perfectly valid thing to criticize me on or suggest improvements for. So check that out. So that's all I have. Unless you have more questions, feel free to throw them in the chat. I do have some slides prepared for questions I get asked a lot. So I've got them already here. If any of these are interesting to you, just shout out a number, like it's a fast food restaurant. And I'm happy to answer those questions. I do have number 3 in there because back when we give these in person, people were always kind of shocked about how tall I am, because you can't see how tall I am from a webcam. But I am 6'6", and I'm terrible at basketball. Absolutely terrible. My daughter is 10 years old, and I think she's already a better basketball player than I will ever be. So no, just because I'm tall doesn't mean I'm good at basketball. But anyway, I don't have a slide for that one, but happy to answer any other questions you have or click on some of these slides. But other than that, I really thank you all for inviting me out here. It's cool to be able to give these remote presentations, but yeah, I kind of agree with the discussion earlier on. I'd rather do these in person, and I'm looking forward to the time where we can do that more, although it was still cool to have kind of a hybrid option available as well. So thank you very much for having me. Thank you, JSON. Make sure to get those raffle entries in by emailing JSON there. I keep calling him JSON. I should say Jason, because I'm used to saying JSON. So sorry about that.